Hey, what's going on, guys? In this video we are going to see an example on superposition theorem. Here what we are trying to find is the current across this 3 ohm resistor. Now to find this one, what we do is we separate this one into three parts. Like, since we have one current source, voltage source, two voltage sources and one current source, so we separate this one into each sources. Here we have current source, voltage source, and when we remove the voltage source, we just short circuit this one, and when we remove the current source, we just open that one, right? You can see that. And actually this is pretty easy to, it's easy to take this one directly and solve this one, but in this one we just, to illustrate the superposition technique, we are going to separate this one into three parts and going to solve this one by one. Now let's start with this circuit, right? So here we are going to use the mesh analysis technique, and let's start with this one. So through the 8 ohm resistor this I1 is going, so that's going to be a voltage drop right here. So we are going to put minus 8 I1, and then it's going through this 4 ohm resistor, so that's going to be minus 4 I1, and also I2 is going in the opposite direction, so we put a negative sign right here, and I2, and then I1 is going through this 4 ohm through this one, so we put again minus 4 I1, and I3 is going in the opposite direction. So I3 is going in the opposite direction, so this is going to be minus I3 right here. Okay, and also here this is one of the equation. Now let's simplify this one. This is equal to 0, and let's simplify the first equation. That's going to give us minus 16 I1 plus 4 I2 plus 12 is equal to 0. So this is our first equation. Okay, now the second equation, we can take it through this I2 mesh, and here let's start with this one. So 3 ohm, we have I2 is going through the 3 ohm, that's going to be voltage drop, so this is going to be minus 3 I2, and also I3 is going in the opposite direction, so we put a negative I3, and this I2 is going through this 4 ohm resistor, so that's going to be minus 4 I2, and I1 is going in the opposite direction, so this is going to be minus I1, and that's it, that's equal to 0. So this is our second equation. Now let's simplify this one. If you simplify, you will get 4 I1 minus 7 I2 plus 9 is equal to 0. Okay, so this is what we have right now. Okay, this is our second equation. Now the next thing is I3 mesh. If you look at this one, I3, through I3 mesh, this 3 ampere current source is there. So if this is I3 is going through this one, and if we have 3 ampere, it means I3 is equal to this 3 ampere. So we don't have to separately go and solve this mesh. We know that I3 is equal to 3 ampere, right? Now, so from this one we are going to solve this one. To solve this one, what we can do is, if you notice here we have negative 16, so to get rid of this I1, I can multiply this one by 4 and add this one with this one, because I have 4 I1. If I multiply this one by 4, that's going to be positive 16. Here we have negative 16, so we can get rid of that, right? So if I multiply this one by 4, that's going to give me 16 I1 minus 7 times 4, 28, 28 I2, 9 times 4, 36. So 36, I can move this one to the other side of the equation, so minus 36. Okay, now let's bring this one here, and that's going to be negative 16 I1 plus 4 I2 is equal to negative 12. I'm moving this 12 to the other side, so this is going to be negative 12, and if we add them together, we are going to have 0 right here, and this is going to become minus 24. So this is going to be minus 24i2, and that's equivalent to negative 36 plus negative 12, negative 48. From this one we can see that I2 is going to be just 2 ampere, right? So this is one of the circuit, but in order to find I we have to find all the I2, and also I3 is going through this one, so finally we are going to come up to this. Now let's solve for I2, because I3 we already know that it's 3 ampere, so we don't have to worry about it. We only have to worry about I2. What are the I2 values? Now let's go ahead and solve the second circuit right here. I use a different color so we don't get confused. Okay. Now again, let's start with this I1. Let's start here. Minus 8 I1, and it's going through this 24 voltage, but it's going from negative to positive. So if it's negative to positive, that's going to be a voltage rise. So that's going to be plus 24 voltage. And then it's going through this 4 ohm, so that's going to be negative 4 I1, but I2 is going the opposite direction, so this is going to be minus I2. And after that I have to do the third circuit too, so let's leave a space for this one. Let's, okay, like this. Okay, so I try to finish everything within this. Minus 4 I1 I2, so we are in this one, right? 4 I1 and minus I2. Then we are moving to this 4. In this 4 we have only I1, because now since we have removed this current source, we don't have anything going through this one. We don't have I3 mess, so we don't have to worry about that one. We're just going to have this I1 and this 4. So that's going to be just minus 4 I1. That is equal to 0. And if you simplify this one, you should get minus 16. Okay, minus 16 I1 plus 4 I2. That should be equal to negative 24. Okay, so this is our first equation. Now let's look at this mesh right here. Starting from this 3, we are going to have minus 3 I2, and then we are going to have this 4 minus 4 I2, but I1 is going in the opposite direction of this one, so that's going to be minus I1. That's equal to 0. And if you simplify this one, that's going to give you 4 I1 minus 7 I2 equal to 0. This is our second equation. Again, you can see that we have negative 16 I1, positive 4 I1. So if I multiply this one by 4, I will get 16, positive 16. So I can cancel them, right? So let's go ahead and do that. Here we are going to have minus, if I multiply this one, that's going to be plus. Okay, let's write that one first. Plus 14 I1 plus 16 I1. 16 I1, and 7 times 4, that's going to be 28 I2, and 0 times 4, that's going to be just 0. Now let's bring this one right here. Okay, that's going to be minus 16 I1 plus 4 I2 is equal to negative 24. From this one we can see that this is 0, this is going to be negative 24. Negative 24 I2 is equal to negative 24. So from this one we can see that I2 is going to be equal to just 1 ampere, right? And previously we had I2 is equal to 2 ampere, here I2 is equal to 1 ampere. That's because we are having the different circuits, right? So we cannot expect the same results. Now let's look at the third circuit. Third circuit, we have this one right here. Now let's start with I1. I1 we have, okay, I take this one outside so you can see. Okay, I1, let's start with the I1. we have, let's start with this 8 ohm. 8 ohm, we have I1 is going through the 8 ohms, that's going to be minus 8 I1, and then this I1 is going through this 4 ohm, so that's going to be minus 4 I1, but I2 is going the opposite direction, so that's going to be minus I2 right here, and then this I1 is going through this 4, so again we are going to have minus 4 I1, and that's going to be equal to 0. And if you simplify this one, you should get minus 16 I1 plus 4 I2 is equal to 0. This is our first equation. Now let's look at the I2. This is, maybe let's start with this voltage source. Plus to minus voltage drop. So this is going to be negative 12 voltage. And then this is going through this 3 ohm. So that's going to be minus 3 I2. Then it's going through this 4 ohm. Minus 4 I2. But I1 is going in the opposite direction. So that's going to be minus I1 right here, and that's equal to 0. And if you simplify this one, you should get, negative, no, positive 4 I1 minus 7 I2 is equal to 12. Okay, so this is our second equation. Now here again you can see that here we have negative 16 I1, 4 I1, so if I multiply this one by 4, this equation by 4, I can get 16 I1, so I can add them with this one and cancel each other, right? Let's multiply, so multiply by 4 times this, that's going to be 16 I1, negative 7 times 4, negative 28, and I2, and here we have 12 times 4, that's going to be 48, and let's bring this one right here. This is going to be negative 16 I1 plus 4 I2 is equal to 0, and if you add them together, this is going to be 0. This is negative 16 I1, and this is going to be negative 24 I2 equal to 48. Therefore I2 is going to be negative 2 ampere. Okay, now from the previous one we found out in the first circuit we had I2 is equal to 2 ampere. In the second circuit we had, let's put 1, 2, the second circuit we had 1 ampere. In the third circuit we had I3 is equal to negative 2 ampere. Okay, now we have all these values. Now let's look at this I. I is the main question, right? Now therefore I is going to be equal to, this is the direction of this I current, and if you look at the measures, I3 is going along the current's direction, along this direction, so we are going to have 3 ampere positive. Okay, and I2 is going, we took it opposite direction, right? Opposite of this direction, so whatever the I2 value we get, we should put opposite sign for that. I2, first one we got 2 ampere, so I put minus 2, and 1 ampere minus 1, minus 2 ampere plus 2, and if you add them together, 3 minus 2, that's going to be 1, 1 minus 1 0, so we are going to get 2 ampere. So this I current is equal to 2 ampere, and that's how we use superposition technique in this kind of problems. I hope this helps. Thanks for watching.